Now we'd like to talk about the Profiler tool. This tool is a new tool in Maya 2015 extension 1. It's just a couple weeks old, and it provides an advanced set of tools or profiling tools to help you analyze your scene files. So it builds up on everything that we've talked about to date. This is accessible from the window pull-down menu, and it is not a plugin. It's built right into the system. So it works a little bit better in the fact that it's integrated tightly with the operating core of what Maya is. Again, it's available to you under the Window, General Editors, Profiler, right underneath the DG Profiler option that we've talked about earlier. There are two additional commands available to control the Profiler: the Profiler command and the Profiler tool command. The Profiler command is the main core. If you're doing any scripting with it, the main piece that you would use to control key events within Maya. It can be used to adjust parameters to the sampler, as well as it provides methods so that you can integrate your own null scripts into the profiler. So by adding categories and things like that we will talk about later. The Profiler tool command actually launches the user interface and is used by the Profiler panel to interact with the Profiler tools view, or the drag region within the Profiler window. It can be used to control some of the behaviors about the Profiler, and only one flag can be used at a time. Typically, the users wouldn't interface with the Profiler using this command. The main command that you would use if you're going to write scripts would be the Profiler command. It allows you to start and stop the Profiler sampler. It allows you to adjust the buffer size and a few other options. The Profiler tool implements a built-in sampler engine to sample the metrics from several different processes within Maya. It provides a CPU and category view of the sampled data. The Profiler also allows you to turn on and off different categories and samplers so that you can clean up or reduce the amount of information that it's showing you at any particular point in time, and the user can save the profile data to disk and read it back, which you couldn't do in the DG Profiler. You can only write that out to disk and then read it into another system like Excel or a spreadsheet application of some type. But with the Profiler tool, you can actually save the data out and read it back in at a different date and time. So if you wanted to compare what you had done, you had gone through and optimized your scene for a bit, and then you profile it and you get a new set of data, you can compare that by bringing it back in and reading that back into the Profiler window. The window you see here is the Profiler's CPU view. You see, and we'll get into the specifics of this in a bit, and you also have a category view of how to look at your data, and this is what that view looks like. So what we've done, we've shifted over into Maya, and we're going to take a look at opening up a scene here. Let's open up our same scene that we had earlier, that city scene, and we're going to run it through this new Profiler and take a look at it and see what it does. Okay, so let's turn there we go. Alright, switch our camera view. There we go. And let's go back to our 3-window layout. I'm going to switch the lower panel from the graph editor that we see here to the Profiler by going under Panels, Panel, Profiler. This is actually something additional that the other plugin mechanisms wouldn't do. You can actually embed the Profiler window into a panel right within your interface, as opposed to it always being an external window. Okay, so what we're going to do here is go ahead and profile this. And to do that, let's switch back to our camera. There we go. Different view. There we go. Alright, so let's just scrub through this to see what we're... Okay. Alright, so what we'll do from this view is to run the profiler, you would click on Start. That will start the profiler sampler and it'll start sampling the scene, and then you can stop it by clicking on the Stop button. Okay, so what we'll do is we'll go ahead and start playing back our scene, and the scene will start playing back, and we'll start the profiler. Once we get a certain amount, what you see what it's done here is it's automatically stopped. Let me go ahead and stop the animation. Because the profiler by default, if you take a look in the lower right hand corner, only has a buffer of 10 megabytes, the profiler, once you start it, will stop after that buffer is full. Once that happens, then you can actually go through and analyze this scene. Using the standard pan button, the Alt and left mouse button, the middle mouse button, you can actually go through and pan the view around. You can also zoom into it. You'll also notice that it zooms, the zoom actually is maintains the aspect ratio. So in a lot of cases you want to be able to actually squish it down. If you hold the shift key and right click, you can actually scale it in the vertical direction or in the horizontal direction, so you can expand out the view or compress or stretch out the view. What you see here is we're in by default the category view, and the category view gives us the view of all these different categories that you see on the left hand side. You have the Bifrost generator, the Bifrost system, XGen, some more of the Bifrost solvers and the scene overrides, as well as QT. The QT is the window interface that Maya uses, which provides for all the buttons and gizmos and widgets that you click on. The evaluation is the Maya evaluation. Then you have your dirty propagation, your change events, your VP2 evaluation events, which are basically viewport 2, which is the rendering events in this particular window here. And then you have the Maya events, Maya main events right here, which is actually the controlling mechanism of Maya, which literally controls all the rest of the events. So you can see all the samples from all of those. The buttons to the right of those, the red button here, turns on and off the recording or the sampling of those events. So if I were to go through and resample this, it won't sample or record any of the Bifrost data. Here again, the same goes true for XGen now that I've turned that one off, and so on. The button to the right actually turns off the display in the profiler panel here of those categories. So if I wanted to turn off the QT, the display of the QT events in the profiler, I would just click on the right button and you'll see that QT event line disappears. And we can do that with all or none of the events. So let me go ahead and turn all these back on. There we go. And talk a little bit more about this. The view here is laid out in time. So right here is our T0 or time equals 0 point, and it goes up in time to the right. The viewer allows you to actually select and look at individual pieces of data. So let me go ahead and compress this. So this is, if you click and drag all the events here, you'll see that it gives you an overall time right here for everything that is selected. So it's telling us that everything that we have selected literally took 3,892 milliseconds to process. That's quite a bit, actually quite a bit of time. It's about, obviously you can see it's about 3 seconds worth of time. Okay. Going back to the left side of the window here, we have under the start and stop buttons a save button, which allows you to actually save this data to disk. If you click on this, you'll get the file dialog window and asking you for the name of the file that it's going to save, and it saves it out in a text format. And then you have a load function that actually allows you to load a previous profile from disk back into the scene. Once you do that, whatever was in here before automatically gets flushed out, and the new data gets loaded. Okay, so what we want to do is we're going to go through here some of the main menus. Under the edit function, you have a find, which is also available right here, and it allows you to find events for particular items. So for instance, if we wanted to go through and find all the events for, let's get the name of one of these events here. Let's do this event here, which would be the OGS render. So you just type this in to here and hit return, and it will find you all of the OGS render events that have happened in this particular profile sample. That gets handy if you're trying to look and trying to analyze the evaluation of a particular node type set, like joints that we'd looked at before, or a deformer. Maybe that would be a joint deform or joint cluster, or a blend shape. You can actually type that in. It will highlight those, and you can take a look at them and analyze them from there. So as you can see here, we have quite a bit of sampled data here, and it's going to be kind of difficult to go through and dissect parts of this by looking at all the whole. Yeah, I can zoom in on this and get in and look at individual pieces, but I've written a script here, a little Mel script, that allows me to sample one frame of this animation and display that sampled data in this window. What I want to do right now is I'm going to bring in the script here and show you and go over this real quick, how it's built, and you can feel free to use this if you wish. Like I said, I've got this attached to a hotkey, and we'll go over how it works in a minute, but I want to go through the workings of this script through the script file here. Basically, it's just called profile frame, and one of the first things we do here is define our buffer size. Instead of using the 10 megabytes, I tend to use 100 megabytes, mainly because some of the scenes I start to use get quite complex and pretty big, a lot bigger than what this scene shows. Next thing we do is we get some information, the current time, and define what our next frame would be, and set our playback options to set a frame range. Then we set our buffer, get the name for the scene, some basic housekeeping. And what you can see from this point down right here is where I'm really controlling the profiler using the profiler command that we talked about earlier. Using the profiler -B switch allows me to set the buffer size to that 100 megabytes that I talked about a little bit earlier. The profiler -R command actually resets the profiler buffer so that it clears out all the memory to 0, basically. The profiler -S command starts and stops the sampler. So basically I'm using the on option to that to start the sampler. Then I use the current time frame to go from the current time to the next frame, which is the current time +1. Then I stop the sampler using the profiler command again, -S off, to tell it to turn it off. And then from the output file that I computed up here, kind of computed up there, I actually tell the profiler to save that profile that we just generated to the disk file. One thing I don't want to do when I'm doing these profiler commands is to do superfluous stuff that would affect the sample itself, because the profiler runs by kind of freewheeling inside of Maya, and I can do all kinds of different things. I don't want those different things to influence the profile sample that I'm taking. So once that's done, I rewind the animation backwards one frame so I can see where I was. Okay, so from here, what we'll do, I've got that connected to a hotkey that I'm just going to hit right now, and you can see it gives me a much simpler view of what that one frame that I'm looking at, which was frame number 40 of that profile. So here, going through, I can still use the same, obviously, same commands and controls to control the profiler tool window itself. I'm going to clear this out so that it doesn't affect my my selections here. And what we'll do is we'll go through this a little bit. As we zoom in and take a look, the category views basically start here with the main Maya thread, going through and showing what the evaluations are, where it gets the set time, where it does a set time in my dependent in my DG evaluation, and continues doing other things. As you can see, there's some handshaking, some parallelism here in Maya, that things happen simultaneously in some cases, depending on the what's happening here. The interesting things that I'm interested in are mostly the things that are going to take a lot of time, like the propagation of the dirty messages. Basically, when Maya goes through and says, "Okay, you want me to evaluate something? What do I need to evaluate?" Basically, it goes through the dependency graph and figures out all the connections that have changed and what needs to be recalculated and all that. That's what this DG dirty time is all about. So if I zoom in on this, I'm going to select this, and I'm going to use the A key. I can use that hotkey to frame everything that's in the scene, or as you're more used to, the F key to frame in on the selected elements. So here we can see some of the things that are happening in the DG dirty process, and basically the way you read this this profile sample is from the bottom of this baseline for the category in this case, which is our DG dirty upwards. So what we're seeing here is, let's take a look at the entire time and for these events, and that ends up being not very much, like 1,000 microseconds, which is just barely a blink of an eye. So let's continue on down and zoom out here a little bit and look at other things in this profile and figure out what else is taking some time. The other thing that may take time is the evaluation of, or just the basic evaluation, which is the DG evaluation. That's these elements right here. They're taking about 772 microseconds. Let's frame in on everything. Yeah. So that's not taking much time either over in the grand scheme of things. If we go through this, we can see that, let me zoom down a little bit so we can see all these categories, because right now we're in category view. We can see our main elements, or our main events that are happening down here. You pretty much have a lot of stuff that Maya controls and does throughout the entire frame calculation. Then you have the VP2 evaluation. That's these items above the baseline, and those are just basically Maya going through drawing everything that's in the scene, the amount of time that it takes to evaluate the draw processes. Then you have the Maya change events, which is almost nothing. Right here we have a few ticks in there. Overall, from beginning to end, they're 7 milliseconds. Then we have the DG dirty that we just talked about a little bit, which is about 1.4 milliseconds. Then above that, we have our evaluation, which is an evaluation of the compute methods for all the nodes, where it actually does the majority of all of its work. And here you can see in this particular scene, there's nothing really taking too much time. Let's frame in on this, and we can see what the individual pieces are doing here. So like I said earlier, the way you read this graph is from the bottom up, and let's zoom in on this section right here. this is our expression node. Right here we're doing our the evaluation of our dependency graph nodes. And basically the expression node gets evaluated first. The way, like I said, you read from the bottom up, it then from the left to right calls this function or this node to evaluate so that it gets all the data that it needs to continue doing its evaluation. Let's expand this out to find out what that is. So there's a unit conversion node there that the expression node needs to get some data from. The unit conversion node then needs to get some information from the foot right node, which is the transform node. The transform node then goes up and looks for information from the right foot translate X node, which is our this is actually basically our animation node, the animation curve. So the animation curve feeds our right foot, which feeds our unit conversion to the expression, and then continues on through the evaluation. And each one of them continues in that same fashion. For instance, here's the left foot. It needs to get some information from the foot left translate Y animation curve, and so on. What you want to look for in a nice little trick to know is this is the amount of time that it takes Maya to get that piece of information from that node. And right now that duration is 4 microseconds just to get that animation value. Then the foot left starts to do its work to compute what the unit conversion node needs. You see this gap right here? Well, that's the actual amount of time that, or overhead that this node takes, that it's not actually getting data from other sources. So if we were to take that and subtract these values from that, then we can find the overall overhead for that node. And the amount of wait time that everybody else is waiting for nodes above it to finish computing before it can continue on doing what it needs to do. That's basically the way these graphs work. So a couple visual tricks that you want to look for is some of these nodes that at the top seem to be longer than the rest of them. In this particular case, this foot right node evaluation is about a third smaller than the foot right. So that's kind of telling us that this difference here is this node's taking longer than maybe it could or should take to compute. And that could be because we have static animation curves on there that is still, it's not being calculated, but it still has to go out and get data, and so on. Matter of fact, I'm pretty sure that is it because I didn't clean them up on this particular node. And here again, here's another one where we can see all this computation. It's already got everything that it needs to compute this particular node. This is our expression. So this is basically the overhead of what that expression takes to compute before it's done with its computation, which is let's see, it's roughly 4 milliseconds. Let's see, it's basically, come on, select. It's about 172 milliseconds minus this amount of time, which is 102 microseconds, which so it's taking about 5 microseconds of overhead just to compute the expression. And like I said earlier, if I really wanted to, this is actually running pretty quick. If I wanted to speed this up, I would try to figure out ways to remove that expression node or simplify it so it's quicker, and we can speed up the scene. Okay, so what up until now, everything we've been looking at is in category view. I want to go over some of the more interface tools here. You will see under the edit menu, you have the find, which we talked about earlier. Under panels, we have our typical panel views. Right-clicking inside of the timeline view here in the profiler tool, we have our category view option, and then we have our CPU view option. The CPU view will give us a view of what each core in this machine is doing, and basically what we can see right now is that most all of the computation, matter of fact, all of our computation for that one frame that we sampled happened on CPU 0. If we go through and recompute, then I'm going to hit the hotkey again and recompute this scene. And by continually, that's the nice thing about having the hotkey. I can continue hitting a hotkey and it'll continue to do the evaluation or the sample. As you can see, it's not exactly the same amount of time each and every time I hit it. And the reason for that is, just like all modern computers, it's doing other things in the background. The operating system is running. Right now I'm not running anything else but this session of Maya, but there's other things happening like internet pings and it's checking for my location services are running and stuff like that. And even Maya is doing things in different orders. Okay, so that's the reason why the timings are not exactly the same each and every time I'm running this. Alright, so that's the CPU view. We've looked at the category view. If you take a look at the timeline here, obviously the timeline shows the view of time. It gives us the total amount of time that it has sampled here, which is 50 milliseconds roughly. And then in the lower right hand corner it tells us a total number of events that are hidden in this view, and our buffer size and the amount of buffer size we use versus the amount that it's set to. Right now we've used about 20 megabytes of about 100. Oh, actually, probably even less than that, 0.2 megabytes. So we're not using much at all. Okay, so we talked about the hidden elements right there. The profiler also allows you to hide elements that kind of get in your way of analyzing and looking at your data sets. If I want to, I can select these nodes, and by hitting the right mouse button, I can tell it to hide those selected events. And obviously it hides those events. So it tells us right here in the bottom that we've got 2 hidden events now. Right-clicking on the mouse button gives us the option to hide selected events, hide selected events repetition. So basically that means if I've got a node that I have selected and I tell it to hide events repetition, it hides all of those types of nodes that if they get repeated. That's helpful when I'm doing multiple frames, and I'll get a sample stack like this multiple times throughout the timeline. We can also tell it to show only selected events, so I'm going to select my Qt Paint event. That event is actually somewhere the user interface has drawn a widget or something within this window or within this view. So I can tell it to show only those selected events, and it shows only those events, and that's this Qt Paint event. Also, we can tell it to show only the selected events in repetition, so it will show the repeated units of those events. And then you can actually unhide everything, and by again hitting the A and the F keys, you can use to frame everything with the A key or the selected elements with the F key. And that's basically how the profiling tool and system works within Maya. And the profiler tool that's in this version of Maya is extremely helpful to analyze and debug some of these issues with your Maya scene. And thank you for watching this presentation of using the new Maya profiling tools and scripts to troubleshoot your scenes. Thank you.